You are very much welcome, my viewers. In this video, we'll be considering the complete modeling, loading, analysis, as well as design of the steel structure using a steel truss, and after which we will be taking the structure to the Protek steel right there to carry out the all connections of this structure successfully. So stay tuned and stay connected. Do not forget to like and subscribe to the channel. Soft reasons, as we will be bringing to you more useful presentations of this kind. Let us get started. So we are going to be creating a new project. So we will navigate to the file menu right there and click on the new project right there. So in the new project dialog, we'll be having trusses designed. So we just add a tool to differentiate that successfully. Come down and then we will be using the Euro code and then select OK options. So this is going to create for us a Euro code template that we'll be using for our design. So here is the template. So in this template, we will start by setting out the grid lines. So we navigate to the modeling tab right there, orthogonal axis generator. We pick a point on the drawing interface, and then in the orthogonal axis generator, we will have the direction 1, which is the horizontal direction. So we are going to be considering a spacing of 4 meters. So it is going to be 4 meters into 3 places. Alright. After which we will come over to where we have the direction 2 axis. In these directions, we will be having 5 meters into 2 places. Alright, so we make this into 4 places, just like this. Okay, so having set this successfully, meaning we are having the width of the structure to be 10 meters because 5 times 2 is 10. Alright, and then the length is going to be 16 meters because 4 times 4 is 16 right there. Okay, click on the OK options. So you will be having something of this kind. Alright, so having this now, the next thing you will need to do is to go over to the story right there. We'll be having a total of 2 stories. Of these, each of the story height is 3 meters. So we click in 2 right there, click on the OK options. Yes, options. Alright, so we will be editing the story right now. So click on this menu. You can also pass to the building setup right there, come over to these provisions, and then you can be able to edit story right here. The same options you have when you right click over here. Alright, so in the edit story dialog, at the first story, we will be having it to be from the normal ground level to a DPC level. So we have that to be for 450. So this 450 plus 1100 is going to be the total length of the column that we carry the steel stanchions. Alright, so we need it to be 1200 altogether. So we will have 750 right here. So 750 plus 450 gives us 1200. Then the height of the structure or the stanchion height is going to be 4500, just like this. Okay, so come to the structural system, very important. At the foundation, we have it to be concrete. At the superstructure, the substructure, the superstructure, so we have this to be steel. Okay, so click on OK options. Alright, navigate to story 1. Then go to the modeling tab, click on the column right there. So we are going to be inserting a column of length altogether to be 1200 from the DPC to the foundations level. Right, so we have the section to be 500 by 500 millimeters right there. So we will have that in this grid line 1 intersection, just like this. We also have it in this other grid lines. In these places, we wouldn't have any column because our truss is going to span across that. So successfully click on the close options. Alright, so after which we can now navigate to the story 2 right there. At the story 2, we're placing our stanchions. So click on the steel columns right there. We change these sections so we can get smaller sections of the universal columns right there. So select there. Okay, so we are considering British. This is 303 by 303. It's quite bigger. So let's go by 203 by 203 by 46. Okay, because it's a small structure, so we add that up. So we are going to be rotating in this direction. Click on OK option. So we have it placed on these provisions, just like this, and the same thing here. Alright, so having done this successfully, we click on the OK options, and then we will go to the 3D to see what we have done so far. So we have something of this kind. All right. So at this point, we are going to be placing the trusses right there. Okay. So for the trusses, you go to truss options. So once you select that, pick the first point of the truss, pick the second point of the truss right there. So this is going to show us this. Let's click on OK. You see, we have not actually placed it right. So you have to delete this up. Pick the truss options again. Pick this first point. Make sure you always zoom closely to be able to get the right node point. Okay, so because if you pick wrongly, you may not necessarily get what you wanted. So ensure you always zoom closely, click right there. All right. So we'll be considering this type of truss. Okay, and the pattern is this one. All right. So having this like this, you see it consists of a double angles, back to back, top and bottom. So we may be changing this to using a rectangular hollow sections. All right. So we'll go to the member right here at first. There are some settings we need to do here, but before we come here, let's change the member successfully. So over here for the top cut, we'll be considering rectangular sections, and then for the sections, rectangular section we're considering is going to be 60 by 40, 60 by 40, or we can take it to be 80 right there by 40, and then by 5 millimeter thickness right there. Okay, I think we can go by this. Okay, so click on the OK options, and then we rotate it in these directions. Click on OK right here. So the same section 60 by 40 by 4 for the bottom chord as well. Okay, so rectangular hollow sections 60 by 40 by 4 right there. Okay, rotate it this way and OK. Okay, so for the diagonal bridges, we will be going by square. All right, so we can use this one. So it is going to be square. So we go by 30 by 2.5 right there. Okay, click on the OK options, and then OK again. The same thing for the vertical. This 30, just like this. Okay, OK again. So if you come here, we have also the horizontal members. So we use the same sections, square sections. All right, just like this, and OK. So we have changed the sections. All right, you don't have to click on the OK. Go to the general. Okay, in this general, we are going to be supporting the truss. At first, truss support placement is going to be top. All right, just like this. Okay, so after which you come over to where you have the apex height. So you see the apex height, apex vertical offset. You also see the left heel height. Okay, so all of these things, if you are changing it, you are going to change it accordingly. So we are going to by apex height 1 meter. Okay, what we need to change again right here is the number of spacing we are having here is going to be 6 right there. So click right there in that directions. In this other direction also 6. So we have something of this kind, just like this. Okay, so at this point we want to click on the OK. Then I'll be explaining something to us. OK option there is to have this truss placed. We are supposed to continue to place it, but for now let's get rid of that. So coming to this point now, what I wanted to explain here, if you check this truss right here, it is right on top of the stanchion, so we need to bring it down. Okay, we need to bring this a little bit downward, this point downward. All right, so for us to do that, we have to select the truss again, and then if you check very well too, you can see the depth of the truss is quite bigger. We can also reduce that. All right, so select that, right click and click on the property right there. So in this property dialog, you can easily go to the apex height right there. If you want to be 800, you can change it to 800. The same thing will be applicable to this. Okay, apex vertical offset is also going to be 800, and also left heel, it's also going to be 800 as well. You come down, the right heel is also going to be 800. All right, so we have a uniform truss just like that. Okay, so after which the next thing we will do, when you see left vertical offset, you want to bring it down. Left vertical offset, you want to bring it down. So you prefix it with minus. You want to bring it down with 100, just like this. Okay, then we consider the, sorry, that is the left, the right. Okay, we also bring it down with 100. All right, I will tell you why that is brought down in the course of the presentations. All right, so click on OK option. So you can now see there is now a space between this and this. Okay, the space between the top and then the top of the stanchions and the top of the top chord right there. Okay, so having done this successfully, the truss is now set for us to, you know, copy it to the next stanchions right there. So you select it, right click, make sure it is selected, then you right click. You can see copy options right here, this one, or you can see it over here. So you click on the copy right there. So zoom closely to this, make sure you pick the node point, take it to this next node point and place it there. So you continue to place it. Having placed all the trusses, the next thing we'll be considering is the braces. Alright, so we click on the braces right there, pick this one, this. Okay, so in the braces dialog, having known that the height of the structure is 4.5 meters, which is quite long, we can divide the braces into two. But before then, we need to change the profile of the braces. You can see it is UK angle 90 by 90. We may not use angle, but we will be considering hollow square sections. Alright, so the smallest here is the 40. Let's check this. We have the smallest of this to 25, so we go by 30 by, or you can just go by 40. Okay, let us go by 30 by 30 by 3. Right, this one. Click on the OK options for the braces. Click on the OK again. So that is the profile is being changed successfully. The next thing we need to do is we will have to change the number of counts to be 2 right there. Click here to have a count to be 2, just like this. The next thing we're going to be consider is we are going to be bringing now the support point downward so that it is not going to clash with the beams. All right, so for us to do that, we select the first count, all right, which is the count 1. You come over here, you change this to 300. We are bringing it down 300, just like this. You can see it goes down. So once it goes down like that, you come over and apply it that end. So both ends we are going to apply it to analysis. So we are doing this so that we can be able to run connections there successfully. Alright, so we also do the same thing here. Alright, just like this. Okay, so we are okay with this count 1. Go to count 2. So for the count 2, you also come to J and Y offsets. Okay, and key in 200 right there to have it goes up. Alright, if you zoom close, you can see it move up right there. So we really want it to clash with the stiffener, alright, during the connection. So this is okay right now. Alright, click on the OK options. So we now have something of this kind. Alright, so this same thing we are going to be using for every other provisions. We actually have braces. Okay, for the roof braces, the same thing will be applicable. Select the first truss and the second one to have this. So you can see it done right there. What you just need to do for the bottom count is going to be 0 right there. So come to this bottom count as well, this one, and make it 0. Right, so we are not having this. Okay, so with this we can choose to split this into 2. Alright, by coming to this count right there and change it to 2 right there. Click right there to have it just like this. You can see. So having changed this now, we will now have to select the count, which is the first count 1 right there. Okay, then we'll come to the offset right there. So you can see the property of frame 2 offset is being made. For the property of frame 1 offset, which is this provision, the space between this point. Okay, we wouldn't want it to be actually offsetted, so we'll select that count, which is the count 2, and then for this we have 0 right here. Click here. Sorry, we are not supposed to have 0 here because this is for the count 2. Alright, so if you zoom close, you can see a gap between this and this one. So we wouldn't want this gap. So what we need to do is we select the count 1 right there, and then over here we key in 0 here. Double click here and key in 0 to close this gap here. Alright, so the same thing will be applicable to this side. So you come over here, key in 0 to close also this gap. Alright, so come over here, we need to have an offset of 200 right here. So you come over to high end Y offset and then key in 200 right there and click to have that offset over to this side. So you need to come down to property of frame 2. Okay, the high end Y offset also you change it to 200 and click right there. So we are done with this particular one. Okay, over to this other frame. So we click on this count 1 right there and change it to 2 as well, just like this. So over here we also need to make those necessary changes successfully, and during the changes you have to be careful not to actually make some mistakes that are not necessary. Okay, so at the count 1, at the property of frame 1, we have this space also. So at this point we have to select this, and then we have to key in 0 here, zoom it closely, double click in this position, have 0 here, and click, to close this gap. All right, this gap here. So for this other side, click in these provisions, 0, also to close that up. Okay, so for the offset, come to the I and Y offset in 200 right there, to shift that way, and then come over to the property of frame 2, the same I and offset 200 to have this. Okay, for this other side has been offsetted successfully, so you have something of this kind. All right, as the roof braces. Okay, everything is fine now. Click on the OK options to have the roof braces just like this. Okay, so the same thing I've done here is applicable to all of these places. Okay, so quickly let's just fix that. Alright, so we'll fix the rest. So for this other one, you just have to follow the same procedure, pick this and that, and then you have to make sure you pick it correctly to bring up this brace dialog. So in this dialog, what you just have to do for the count 1 right there, get it selected. So we really want to have this space here because of connections. We want this to be too close, so that is why in the J and Y offset you have to change that to 0 and click outside to bring this close to this member. The same thing applicable here. Come over to this provision, change air to 0, just as I've explained earlier. Then for the I and Y offset, you change air to 300. The reason for this is because we are bringing this down so that we will not have a clash with the beam that's going to connect between these two stanchions successfully. Alright, so the same thing applicable to these provisions, 200 right there. I just want to explain this again. Over here you can see we also have an offset of 300. Alright, for the count 2 right there. Check here. See another offset of 200 here. The purpose for this, we really want to clash with the stiffener, base plate stiffener. Alright, so I believe that is well understood and explained. Click on the OK options to have this. Okay, so we have actually braced the structure successfully. The next thing we'll be considering is the polines. Alright, at this point we select the polines options, pick the first truss right there, and then pick the second truss right there. Alright, you make sure this is properly selected. Okay, trusses are properly selected. If they are not selected, you may not necessarily get the result. So make sure you don't select gates and polines. Let's the polines, pick the first polines, the first truss right there, pick the second truss right there. So you have a polines, just like this. Okay, so for the polines, you will notice that we are having an angle ions for the bracing rod. Okay, so we'll go to the sag rod right there. We really want to use an angle ion, so we change the profile from a universal angle to, or maybe we'll be using pipe, this one. So we select the least one, which is 26.9 by 3.2 thickness. Right, click on the select options and OK options to have this just like this. So after we click on the OK options, so you have your polines being generated just like this. Okay, so at this point now we'll be adding the clouding. This clouding will actually help us to load this structure successfully. Okay, so you click on the clouding right there, and then select the polines right there, and then the clouding dialog will come and click on the OK options to place your clouding just like this. Alright, before we proceed to loading the structure, we'll be having a beams that is going to actually connect these stanchions together successfully. So we have to navigate to the plan view of level 2. Okay, we are already at level 2, so get to the plan view. Alright, so in this plan view now, we want to be fixing beams. Alright, so the beam, we select the steel beam right there, and then in the dialog you just have to choose one of these smaller sections of the universal beam right there. So we use 150 by 89 by 60, 16 thickness. So click right there and OK. So we have to pick that from one point to another successfully, so we wouldn't want to miss load. Alright, we can also place this or fix these beams while we are in the 3D view. So let's close this up and navigate to 3D view so that we can actually see what we're doing to avoid missing the node. All right, so at this point, go back to the beam again, select that. Okay, we are having the same section we selected. Just confirm, and just confirm that. Okay, just confirm that is the sections. All right, this one. Okay, so click on the OK options and OK. So we will be taking it from one beam to another. All right, pick that and then take it to the next. So we'll be taking it from one column to another. So pick that first column, take it to the next one. Placing it like this is more accurate than placing it across. Okay, you may miss node, and then once you miss node, you may not be able to have your structure connected in terms of connections. So you have to just calm down to ensure that you get the exact node point to place these beams successfully, just like this. So we get to this other side. So we pick the first one. You make sure you zoom closely and get the node point. The exact node point will actually show you the star right there. I see a green star and not the red dot. Okay, come over here. Once you see a gray star, you click like this, click. All right, that is the exact point of the node. So you must make sure that you are careful not to misplace the beam of the node. All right, just like this. All right, so having placed this successfully, close this dialog right there. And then we are good to load this structure for now. So we are done with the modeling of this simple warehouse or simple steel structure. So we are going to be loading the structure successfully. So before then, I have to save this. So having saved this structure, we will navigate to the the loading options right there. At first, we'll be considering the load cases and combinations. So we click on the loading generator. Alright, so this is just a small structure. We wouldn't consider the horizontal combinations. Okay, only the verticals and load combinations we consider. Click on the OK options. So you have that. Click on the OK option as well. So now we want to be applying the live load on this steel roof. Okay, the live load and the dead load on the steel roofing sheet, which is the clouding. So what we now need to do is to go to the load editor. Click on the load editor, so it will take us there. So at this point now, we will be considering only the roofing aspect of this. So we come to where we have clouding. Click on the clouding, right click and filter it. So we'll be having only the clouding, just like this. Okay, so we'll be considering a full uniform area load. We have various loads here. You can say point load, full uniform load here, and the rest of that. So the one that is suitable for this kind of loading is the full uniform area load. So click on that. So once you click on that, you will have over here the G load, which is the dead load, and we have the Q load, which is also the live load successfully. So for the load value or the magnitude, we come over here. We'll be having for the G load, we have it to be 0.17 kilonewton per square meter. So we just have to do a window over the roofing area, release the hand. Once you release your hand, you see the load is being placed successfully. But in this case, since we do a window, that's why you're having it placed twice. So you have to delete the second layer of the load. So you go to the front right here, like this, and then you have to have this selected, just like this. You get this selected, hold the control key while you are selecting it. We are going to delete the second layer, this one. Alright, we'll be deleting the second layer successfully, like this. Right click and then click on removed. It's off. Alright, so we can get back to 3D right there to see it, just like this. So this one now is the dead load, which is the G load. We can go to the Q load, select Q, so you won't see anything. So you can see the loads abbreviations here, Q. Alright, so there is no load for the Q. Click on the uniform load. So we also be using for the live load, we just use 0.2 kilonewton per square meters. So do a window over the roofing area, release your hand. You have also two layers loading. So go to the front. We are going to be removing the second layer. Okay, so select that, just like this. Hold the control key, continue to select. Make sure you do not select the second layer. Right, only the first layer we are removing. Right click and remove it, just like this. Go to the 3D. So we have our structure fully loaded successfully, just like this. Okay, so after which you can now select this clouding, right click and clear filter. So once you clear filter, you can see all the loads. Okay, this one is the P load, so you can navigate between the loads. So this is the G load. Alright, this one is the Q load. Alright, so the structure is loaded successfully. What you don't need to do, click on the OK options right there. So this is loaded now. Alright, if you want to check to confirm that, click on this load editor again. So once you click on the load editor again, if you did not see this load, it knows that the load is not actually applied to the structure. Alright, but since the loading have been applied, you see all of these load signs on the roofing area successfully. Click on the OK option to have this. At this point, we will save this project. Having saved the project, we are going to be setting the materials and as well check the structure for modeling check. Go to the analysis right there, click on the building analysis. So in the building analysis dialog, you go straight away to the analysis options, click on building model check. So we check the model for errors, which is for modeling error. So we have a zero error right there. Click on the close options. So our model has passed check. Before analysis, we need to set the material. So we go to the pre-analysis provisions where we have edit material. Click right there. So we will be having our material reinforced concrete strength. We will have to edit that. We use 20/25. Apply it to all. Click on the OK options, just like this. Okay, for the steel strength, we select there. We use 460 right there. Select apply to all. Then we need to edit the rebar diameters right there for the foundations columns. All right. So we select columns right there. So we're working with columns right there. So we wouldn't need 12. We have 16, 20, 25, 32. We don't want 32 right there. So we uncheck that. Okay. Come to the links right there. Uncheck the columns. All right. For the links, we will be considering 8 and 10. Uncheck 12 and 16 right there. Okay, we wouldn't have any other reinforced concrete members in this structure, so we are okay with this. Click on the OK options. But how about the foundations? All right, for these foundations, you just have to untick this. Click on the footings right there. So come over to where you have our footings. Okay, we need 16 right there. We wouldn't need 20. We need 16 and 12. So you have to uncheck this to see other provisions. So over here we have 12. Yeah, this is 12. Okay, so we need 12 and 16 for the footings. Alright, so click on the OK options and then OK again. OK again. So we are done with the material settings. Alright, so you can go to setting center and be able to confirm all other settings in these provisions if need be. Alright, all that setting, like if you come to the foundations, you will notice that this foundations is being double reinforced. So you can uncheck here, uncheck this place and check this place to be able to have a single reinforced foundations. Alright. Okay, so we click on the OK options. You can also change allowable stress on soil over here. So it all depends on what you have at the soil report. Let's use 140 kilonewton per square meter. Click on the OK options right there. Okay, so after which at this point you close these provisions and then you save the project. So now the project is due for analysis. It is due for analysis and design. Okay. So we navigate back to the analysis tab right there, building analysis, and then in the building analysis we will get straight away to the analysis provisions right there. After which we are going to click on the building analysis to start the analysis of the whole structure. So batch design options, we need the program to design, analyze and design the columns and the steel members, and then click on building analysis. So we have to give the program some seconds to carry out the analysis and as well design the various steel members such as the stanchion, which is the steel columns, the reinforced concrete columns, as well as the pole lines, and then the trusses, both the vertical cord, and then also design the bottom cord, the top cord, the braces, and as well as the pole lines successfully. So the design is done successfully. At this point, we'll click on the OK options. You can check the direction 1 and 2 story. Related story draft satisfies the limit. Okay, right there. So you have this. Okay. So in the design, we did not encounter any interruptions or error. Alright, click on the closed options. Right. So at this time, we are going to be checking the structural element to see if they have actually passed the design successfully. So at first, we'll check the reinforced concrete member, which is the column right there. So you navigate to the story one, because that is the story where we have that columns is, and then select it, right click. So we will be considering the arrows. Selected the active story of the columns. You have this. So these are the ROC column sections. You see, it is not designed. So what you just need to do is you click on the column design bash mode. So once you click on that, you will have this dialog. Select this provision. We select all bars and click on calculate. So you allow the program to, actually calculate design the column section successfully. Alright, so click on the close options. So if you check now, you can actually see all of the column has been designed successfully. The steel bars has been selected as well. So we're done with that. Close this dialog. We want to be checking the steel stanchion if actually it is designed. So you get it selected. Alright, you right click and then click on the steel member design right there. So this will open up a dialog that we will be able to check and confirm that the steel stanchion has passed design, as you can see, and the U ratio you can see is very far from 1. That simply means you can increase the section. You can reduce the sections of this steel stanchion successfully, and it will still be able to, carry the structure. So click on the OK options. We'll also check the steel trusses if they have passed design. Right click right there, select the steel member design. So this dialog will also let us know that this steel members has actually passed or it has failed. So you can see the slenderness ratio has actually failed in some of these sections, which is not a problem, but the design started as passed, which is the most important area we have to consider and look at. So another important thing you will have to also look at is the materials strength. So you can see the material strength is almost the least material strength that it is been selected. So for you to be able to overcome this slenderness ratio, what you can do is you can actually increase the thickness of the sections, okay, or you make the section to be less slender, like you make it shorten. I believe that this can be also corrected at site during fabrications. Okay, so the steel trusses are quite very okay. Click on the OK option. So over here, let's check the police. Select that, right click, and then click on the steel member design right there. So here, as you can see, we have the statute passed. Everything has passed design successfully. Alright, click on the OK options. So I want to check all the structural members. We can also check the roof braces. This one, select that, right click, and click on the steel member design. So you will notice that our braces has actually passed design as well, but we have a slenderness ratio. Okay, but for this, if we split this at this point and then we have at this junction where these two braces met, if we have a kind of connection there, is going to solve this slenderness issue actually. So that is not an issue that can be corrected. Okay. Alright, so if you want to get a Protastructure that actually run design of this kind successfully without an issue, just as I've done, you can actually inbox me, okay, through the links in the description of this video. Alright, so this Protastructure 2022 versions. So at this point, analysis and design is successful. Now we will be designing the foundations. Alright, so we navigate to the story 0. At the story 0, we will enable the plan view of story 0 right there. Alright, so we can design the foundations in group. So we can at first design the ones at this grid line 1 all together, or we can design all together, or we can design it one by one. It all depends on what you actually want. So at first, let us design the first column there at this intersection E1. Right click, having selected it, right click and choose insert path footing. So the type of foundations we'll be considering is the path footings foundation. Right, so having selected that and select path footings, you give the program some seconds to actually calculate and come up with the path footings dialog where we can proceed for the design. So just like this, as you can see, we have the path footings dialog like this. So we have the depth of the foundations to be 450, thickness of the foundations. All right, so we are having ls and ly to be ls and ly, ls 1.2 and ly 1.1. so we can actually square it right here and then turn this up to 1.2, take this to 1.2, so I have a square footings just like that. Okay, can come to 3D right here and then you'll be able to left click, right click, hold and turn this, so you have the reinforcement arrangement just like this. During the settings, we are able to set this to be a single reinforce and not a double reinforce. So you can see, click on the OK options to insert these footings. So this is a single columns foundation design. Alright, so to consider a group design, you have to select the numbers of columns you needed to actually add foundation to it, just like this. Right click on it and then click on the insert path footings. So once you click on insert path footings, it is going to come up with a dialog just like this. Okay, so what you need to do here is you have to actually, you can group all of this as well to be one. Okay, so if you want to group it, you need to select redesign all first, select the first one, or the control key, select the last one, sorry, or the shift key, so that you get all selected just like this. Then click on group these options. So this option is going to group all of this to be one, after which, having selected the redesign all, click on the design all, alright, option. So once you click on this design all options, it is going to design all of these footings and give us the footing size, the ls and the ly successfully. So you can see the design status here. It's showing this x, red x, meaning it's not designed. So once the design is done, it will show us a green check just like this. You can see now green check. Alright, so we're having ls, ly to be 1.4 by 1.6. so this is one of the disadvantage of designing by grouping, because it's going to give you a larger sections of the footings. All right, because it's going to pick the highest footing size and use it for all of the rest footings successfully. So let's say we go by this, we agree by this, click on the OK options, you have the footings inserted just like this. Okay, so the same thing is applicable to this other directions. Get all selected, right click right there, and so you select insert path footings options. So we are designing all. Alright, just like this. As I said earlier, we design all. Okay, you can't forget about grouping and then you design all of this. Okay, so you select design all these options. Alright, so we did not use group selected. Alright, options, we didn't use group selected options, we only design all and then we design all. So in this case, you can now see that we have various sizes of the ls and as well as the ly. Okay, but if you group it, it's going to take the highest sections, which is this column 1C7, which has the highest section, and use it to design all. So with this, you can make it a square. Like for this one, we're having ls to be 1.2 and the ly to be 1.1. You can increase this to 1.2 just like this. Alright, so for this one, you have to increase this 1.4 maybe to 1.5 and reduce this to 1.5. It may pass design just like this if you want it to be a squared. Alright, so for this one I have 1.6, you have to like increase this to 1.2. What we are going to be looking at is the, let's see, we will be looking at taking it to Protek to design the connection successfully. So for us to do that, what we have to do first, let us look at the moment diagram of the structure. Alright, so in order to do that, you just have to navigate to this one, where we have the
like this. Okay, so this
Come to the analysis tab right here.
Like
See where we have an
analytical
analytical model. Click on the analytical model
design,
and then
yeah,
you give it some seconds to come up.
on it. Okay,
Alright, just like this. Okay, it is still coming up. Okay, so here is the analytical model
design.
So with this now, you can check the movement diagram of the whole structure by clicking on the diagram right there. So once you click on the diagram, it's going to show you the diagrams as well as the load forces, as you can see. So you can remove the level, right, and actually go to M3, which will actually show you the bend the moment. Alright, just like this. So we can go to V2 to actually see these shear forces successfully. Alright, so you can also go to solid and then you can create a contour and then you have your structure in this format. Alright, so if you are doing a presentation, you can actually add the solid part of it with either the load in Newton or the moment, just as it is showing, just like this. Okay, so having done that, let's get back to the physical model. Right, this is the physical model, this other one is the analytical model. Alright, so we make progress. We want to be diving into Protastructure, so we go to the drawing and report right there. So we click on the Protastructure right here, this one. So we just have to left click on it once. So once you left click on it, give it some time to load. It is going to load and then come up with the Protastructure interface, as it is going to take all the project into Protastructure, so as for us to start the steel connections design successfully for all the structural elements of this steel project. So that is the next thing we are going to be doing. So it's going to be an interesting section that we will have to exploit most of the tools in Protastructure. Okay, as this is a complete training video on how to actually use connections in Protastructure successfully. So here we go, we see the structure being exported to Protastructure. So here is Protastructure interface. So the first thing we have to do, we will start by creating our braces connections successfully. So for you to create a brace connections, what you need to do is you will have to come to where you have brace connection. See these options, click on that options. So you can see various options here. So this quarter weighted gusset, you only use this when you have a base plate here. So you can connect the gusset to the base plate and as well to the stanchion to be able to fix the braces successfully. Alright, but in this case we don't have, and this is quite distance from the from the base of the stanchion. So what we do, we use this weighted gusset plate, these options. Okay, so how do you use it? Click on it, left click on it once and then select this stanchion, select the brace, right click to insert a plate just like this. So you can see how modern it is. Alright, so if you double click on this now, I want to show you something. A dialog will actually come up just like this. You will notice this provision I key in as 0. If for instance this 0 is not there, maybe I get rid of that and I click on apply it. Look at the way the plate will be. So this is not model at all. That is why you have to feed in 0 here so that you don't have an excess plate. Alright, so once you click 0, click on apply, you have that. So click on get and okay. So we are done with that. Okay, the same thing applicable to this one. So you have to select the primary members and these two members, right click to insert and place your gusset just like that. Okay, the same thing here, right click to insert that, and this one, this and that, right click to insert that. Alright, the same thing here, right click to insert that, and here right click to insert that. The same thing applicable to this roof brace. Okay, this roof brace, if you zoom it closely, just the same method you will use. Okay, what you do, select this member, select these two just like this, right click to insert that. So you can see the gusset, the way it looks, very modern, it's not clashing with anything, you can see. So this is how you actually fix all your gusset plates successfully. So having understood that, let's move to polarings connections. So sometimes there is an option we call interlink connect. So in a small structure like this, I would advise you shouldn't use interlink connect. You should just connect them one by one so that you can have a neat connections. Alright, So for the polarized connections, you can actually navigate to where you are polarized and get here. So you right click on this to get the dialog, so you can do some settings in this dialog. So now I'm using angle type. So anytime you select angle type, make sure you click on this reverse clip. So once you click on the reverse clip, what you just have to do, click on get applied and okay, so that it will not find it difficult to actually connect. So select this once, select the polarized top cut of the truss and select the polarized, right click to insert this. You can see just like this. So the same thing you will do to all. Alright, if I should do all in this video, it will actually kill a lot of time. So you can see how it's been done. Select it once, select the main top cut of the truss, the first polarized, second polarized to insert that. Okay, just like this. So you can see. Alright, so we have done the polar connection successfully. The next connections we are going to be looking at is the base plate connections. So for the base plate connections, at first we navigate to the base plate connection provisions here. We have our base plate here, this one. So expand the micros. Alright, so at default you have something like this. Once you click on it, just select the column, you have a base plate like this. So this is not a default base plate, this is a base plate that I've already set. So I will be explaining the settings that I did. Alright, I will explain the setting that I did to have this base plate model just like this. So what I will do, I will have to select the micros by clicking the main base plate selected and then hold the control key and M on the keyboard to get the micro selected and then enter on the keyboard again. Then I will now have the dialog, okay, coming up just like this. So in this dialog now, you can see I've already trimmed from the stanchions to the edge of the base plate. I have it to be 100, you can see here. And then I uncheck P4 and stiffener P4 and stiffener P1. The stiffener is supposed to be at the edge here, and the one that's supposed to cut across, I wouldn't need those ones, so I have to get rid of that. So if you get to the plate itself, you can see here we have the thickness of this plate to be 16 millimeters. So the thickness of P1 is 12. Up to P3 we only have P4 because we have removed it here. Alright, so go back to these provisions. So the height of the stiffener is you can see the height of this stiffener now is 200 millimeters. Alright, so we have also the chamfer to be 50 by the height, and then by the length you have it to be 50. But for this one, because this stiffener is the one at the center or the width of the stanchion, so we always make that 100. Okay, just like this. If I click on apply now, you can see the changes right there successfully. Okay, so here is the distance from the edge of the plate to the edge of the stiffener is 10 millimeters. Alright, so these are the necessary setting I did. The next setting that I want to explain to us is the anchor holes. If you click here, you have an anchor holes just like this. So if you check in this, you see you have 2 anchor holes here and 2 this other side, 2 the other side. Okay, so we have 4 here and 4 there to have up to add up to 8 number of anchor holes. So I will put OK for now, and then I will turn it over, orbit it like this. So you can see 1, 2, 3, 4, 5, 6, 7, 8. So some person will say this is much. How do you reduce it? Okay, so how to reduce it or how to add it, I want to explain it now. So I will keep it on the enter key on the keyboard because I still have the micro selected. Right, so with the dialog will just come up just like this. So once you have this dialog like this, I will remove this 40 I'm having here, and then I will first have 40 behind here, since I wanted only 2 O's at this first and not 4. So I click on apply now. You can see I'm now having only 1, and the distance from the web to where the hose is located is just 40. So this distance now I can manage it by pushing the hole outward. So for me to do that, I can key in here to be maybe 60. So the same thing I will do on this other side. I will key in 60 right there. Alright, click on applied. You can see the hole has actually come up. So I'm having altogether total number of 4 holes. Okay, total number of 4 holes on this plate right there for the base plate. Alright, the bolts diameter is 20 and then the tolerance is 2. Alright, so everything is good now. For the shear key, I will leave it at default right there. Okay, so I click on the get options, applied, then I'll click on OK, just like this. Alright, so you can see now everything is very modern and nice. So if I zoom closely, you actually see that the gusset plate for this connection is almost touching this, but it is not clashing actually, so you can leave it. All right, otherwise we can also reduce the height of the stiffener. So if maybe you want to reduce the height of the stiffener, you need to select the micros again and enter. So once you select the micros and enter, the dialog will come up. So once the dialog come up, you come straight away to where you have plates, and then you have plate thickness of 180 right there instead of 200. So you can just have all the plate thickness to be 180, or you can actually reduce this thickness if you want to reduce the center one, which is this one. Okay, but I prefer reduce it all together, just like this. Okay, click on applied. So click on the OK option. Alright, so now if you update it, you can now see there's a little space between this gusset plate and the stiffener right there. So this is good. Okay, so now we want to place the anchor bolts. The anchor bolts, you come to the miscellaneous, still detailing, expander micros. You can see the anchor bolt. Right click on it to carry out settings. We have two types, C type and the simple type. We will consider simple type. You come to the geometry, and then you can see we have over here 60 for the bigger washer. We wouldn't want this bigger washer, but we want the smaller washer right there. Okay, so in these provisions we key in 0 right there. So for the name is M16, so we consider it M20 because the diameter is 20. All right, the old diameter is 20, and then we have tolerance of 2, which make up 22 millimeters. All right, so for the height, you can see we're having 460 right there. It's adjustable. All right, so you click on the get applied. All right, this has changed to 70, so you have to reduce this. I wouldn't want this. Okay, get applied and okay. So now just select this, right click, and then select the plate to install this. So you notice the bigger washer is still being inserted, which I wouldn't want that. Okay, so you can also undo that to get rid of that. Then right click on this again, get back here. This 70 is what is causing that. I'll change the 70 to 0, come over here, change here to 0 again, just like this, and you can apply it and okay. So click on that, right click and select this. So you now see we have gotten rid of that bigger washer. We have only small washer and 2 nuts right there. So this is good. So this is how you set your best place. So you can actually hide this to see what you have done. So this is what we have. Okay, this is the best plate, well designed like this. Okay, so the next thing we'll be considering is the truss connections. All right, for the truss connections, we are going to be using the micros right there. So come to these provisions where you have truss connections right there. Minimize all of this, open the truss connections. So you are having this for one of these end connections right here. So if you select this now, what you do is you pick this and this, right click to insert this, just like this. Alright, so this has been connected to this stanchion. Select this top, select this diagonal, right click to insert this, just like this. Alright, so this is how you actually connect this. You can see successfully it's connected and it's modern enough. Alright, so for this other side, you can choose to use a brace connection. This one, you can use this one, you can also use this one, also use these two. Any of these two will work out. Alright, so pick this first, this and this, right click to have this model, just like this. The same thing applicable here, so you can see. Alright, so this same thing is what you are going to do to all of the trusses to be able to connect the trusses successfully, just like this. So I may not do all, just try to show us what we are supposed to do. Right, I think this is okay. So this same thing you will do to all the trusses successfully. So we are done with that connections. The next connections we will be looking at is the beam connections. As we are modeling this, I also told us that the reason why we are bringing this down is because we wouldn't want this connection to have clashed actually with this braces, the beam to column connection to have clashed. So let's get beams to column connections, which is this micros here. So we cannot choose between any of these to use. Okay, so let's try this fill plate connections. Select that. First of all, select the stations before you select the beam itself. Right click. So give it some time. It is booting. Just give it some time. Give it some time. It is booting. So we are going to be considering the fill plate connections. Alright, so here is the fill plate connections. You can see the way it looks. Alright, so that is being connected successfully. You can try other connections like this one, this stiffened end plate. You can try that. Select this and this, right click to insert that, just like this. So column and the beam, right click to insert that. Okay, so you can use as many of these connections. Which of any of the connection you choose to use is perfect. All right, anyone that is not actually working, you can change it to which other ones that you think it can work for you, and you can actually use it to do your connection successfully, just like this. All right. So this place, let's try that again. Select the column and the beam. So you have this. All right. Okay, so we are done with the beam to column connections. Almost we have done all the connections. We have done connections for the base plate. We have done connection for the braces. We have also done connections of the lines, the trusses, and then we've done it for the beams. Alright, so in your whole project, you just have to make sure you finish up the whole thing. This video we will be considering the drawings. Okay, we are going to be producing drawings of this steel structure. So I will take us through the right way to carry out drawings generations in Protastructure successfully. But before then, I want to be introducing you to a template we are going to be using in this presentation. So in this presentation, we have a Protek company detailing template, okay, and we also have steel warehouse design template, okay. So these two templates are the template we're going to be using. If I should double click on this folder, you will notice that I have a template right here, okay, for beam or raft on beam foundations. I have Protek structural detailing template for part footings and as well for pile foundations, slab raft foundations, and as well as wide strip foundations. Okay, so these are various foundations, okay, and the templates which you can use. But in this case, we'll be using the part footings because we are having some part footings and pedestal right there. So we'll be using this template. All right, so the links to this template is in the description of this video. So if you download it successfully and then you open it, you will find altogether 1, 2, 3, 4, and 5 AutoCAD file inside of that template. Okay, while this one is the steel template, if you also download it, you find it in a zip file like this. You just have to extract it, okay, without a password. All right, and then you have this. Once you double click on this is going to open for us in AutoCAD. So all of the steel drawings we are going to be generated, we will be copying all to this template for ease of editing. So the link to this template is in the description of this video. So this is a complete warehouse and workshop drawings, okay, detailed drawings just like this, as you can see. So with the help of this steel drawing template, you will be able to actually edit and arrange your steel drawing successfully. That is the main purpose of this template. You can reference this, how all of this has been, you know, arranged and as well detailed, and be able to detail your own steel drawings. Okay, this is all together, it is all together about 30 pages, okay, for this particular steel drawing template. And as you can see, it contains almost all the informations, the bar bending schedule, the steel weight, and the rest of that, because the foundation of it is on concrete. So this is the concrete aspect of it well detailed. Okay, so with this, it is going to actually help you in your steel design drawings and detailing successfully. Okay, so the link to this template is in the description of the video. I'm just showing you this template because we are going to be using it. Okay, we'll be carrying all the drawings we produce, put our steel to this particular template, so we can be able to edit it successfully.
So let us make progress. At first, we are going to be producing the foundation drawing of this design. All right. So since we have already checked all the pedestal, everything is being designed as well as the foundations in the previous lesson, we will just have to proceed to the Protek detail right there. So if you click on the Protek detail right there, so once you click on the Protek detail, it is going to launch us into Protek detail successfully. Here we go. So you just have to click on auto generate details. So once you click on auto generate detail, it will come up with a draw detail dialog, just like this. Click on draw right there, and then you just have to click anywhere in the seed environment to be able to generate your drawings, just like this. So here is the foundation drawings generated successfully. You can see the part footings as well as the pedestal. All right. So here are the details. Okay. So here are the footings details as well. Okay, and this is Protastructure 2022. Just as I said earlier, if you want this program, you can contact us through the link in the description of this video. Will assist you to get this program successfully. All right. So after which we'll be exporting the whole of this to AutoCAD. So you click on this, right click, then click on export right there. So we'll be leaving the name as drawing one, and then we'll choose the lower version of AutoCAD 207, and then click on the export right there. So this is going to actually export us and open the file directory, so we can be able to double click on it so that it will open in AutoCAD just like this. So you click on the continue opening DWG file, which the drawings will be generated in AutoCAD just like this. So once your drawing is here now in AutoCAD, what you just need to do, highlight all of these drawings like this, right click, and then you come over to where you have a copy right there. After you have it copied, you just have to navigate to the template right there, Protek complete template. Double click here and then come over to the type of foundations you are designing, which is the part footing foundation. So double click right there. Once you double click, it shows you the old drawings arrangement for this part footing buildings. Okay, this building is being designed, okay, successfully, and then the foundations is part foundation. So here is going to be a kind of a reference drawing for us, and also you can also pick some other important items here and use our drawing successfully. Okay, and then the order of arrangement of our drawing, you have to take this order of arrangement of drawing to be able to get the exact, order of arrangement of your drawing, even as you print it out. Okay, so having come to this place, you have to right click and then go to clipboard and paste all of the drawing you copied here. So once you paste all of this drawing here, you can see the changes this template has made to these drawings. It has added the thickness and as well as the font to this text successfully, and the rebars. So with this, now you can start to edit your foundation successfully. If any of these foundations is carrying the same size, there are already edited footings here, so you can just copy these footings and make use of it at ease. You can copy any of this column and then edit it. Just few editing you will do on it, and then you are done. So this is the main point where this template is very, very important. So we are done with this one. So let's get back to Protek steel so that we can continue from there in generating the steel drawings of the steel structure successfully. All right, so here is Protek detail. So in this extent, we are going to be generating drawings, but before then, if you check very well, you will see that I have some other views right here. So I want to be taking you 3D views as first. So this one is the active view, which is the 3D view. All right, so if you double click here, you have the plan view. So this view is also important to us. Okay, so it's important to us. We will put it as well inside the drawings, and then if you come over here, you have another plan view at that level. Okay, then if you come to the story to line here, it will show you the roof. Okay, this is very, very important also to us. So we are going to be sending all of these, okay, to the details drawing environment, so that we can actually take them to the template right there. So you double click on the elevations one right there. So this is just like the length aspect of the elevations. Okay, the length, then the width elevations. I will be showing us how you can get that the same way I got this length elevations of the structure. So let's get back to the 3D right there. We have this. So this way is the width and here is the length. So the one that we've gotten so far is the length, which is on the grid line 3. All right, so we are going to be having another section at grid line E. All right, so you go to the view right there, and then you click on view by 2 points. Okay, So you zoom closely to gradient E at this point, pick that point, come over to this other point and pick that. So it's going to view it for us just like this. Okay, so this is the width of the structure, all right? So you can see all of the gusset plates, okay, and the welded connection successfully. Okay, so what you see in this one is a micros. You can actually disable it from that point. Okay, just like this. So with this, just double click right there, and then you just write it as the width elevations. Okay, so you can just put it as the width elevations right there. Width elevation, just like this. Let's make this capital letter like this. All right, so after we click on apply right here, so it will reflect here. All right, click on the OK options just like this. So we have gotten these elevations now. The next thing we have to be doing is we'll get back to 3D. Double click on the 3D right here. Okay, so at this point I want to show you how I created this details, this detail connection box. This detail connection box is very, very important. It is this detail connection box that give you something that look like this. Something that look like this. So you can see this section here. So this one is in the still templates. Okay, so it is the detail connection box that give you this. Okay, so that is the function of the detail connection box. You're going to call the sections like this for you. All right, so let us get back. So we continue. All right, so I will show us how to create the detail connection box, maybe for 1 or 2 places, so that you can actually have an idea on how that is being done successfully. So as you can see, I have it in about 1, 2, 3, 4, 5, 6, 7, 6 places. I have it. Okay, so you look for those provisions where you needed to have a connection that intersect at a point like this point, and then you create the box. So the detail box, it will actually create the connections in that provisions for you. So what will you do if you want to do that successfully? Let's, for instance, we needed to actually create a detail connection box for this particular place. Okay, so you select the connections that you wish to create the detail connections at. Okay, so having it selected like this, you come all the way to the still tab right here, and then click on this detailing items manager, this one. So once you click on that, the item manager dialog will come up. So these are the details I've created already, the 6 ones I've created. So for this one now is for gusset plate connection. So I'll just key in their gusset just like this, gusset, okay, count like this. So once you have to first of all select the connection, all right, before you click on the detailing item manager. So in this dialog now, you key in the name of the connection right there, click on add. So after you click on select, now you have to select all the elements that's actually being connected to the connection. So I'll select this one and this one, after which I right click. Once I right click, I will have this. So you can see the way I managed to place the detailing items manager right there. So I will want to see the 3D of this connections point. So I will click on plus sign right there to actually add the 3D right there. Okay, so after which click on the close option. So the detail is being added. So this is how you can actually create a detailing items, okay, using the manager successfully. Okay, all right. So after having done that, the next thing we are going to be doing is we are going to be numbering the structural elements. Okay, so what we need to do is to get all of these structural members selected. So once they are selected, we go to the drawing and report right there. So you can see perform numbering. So click in the drop down, the first option, perform numbering, click right there, and then you click on the applied and start numbering right there. So you give the program some time to be able to carry out the numbering of all the structural elements successfully. As you can see, the numbering is ongoing. So numbering completed successfully. You can see, click on the OK option. So in the numbering option dialog, you just have to click on apply right there and then click on closed. So having numbered all of these now, we are going to start producing our drawings successfully. So for us to produce drawings, there are 2 types of drawings you have to produce, but we'll be considering the first one, which is very, very important, which is the assembly drawing. We have the single part drawing, we have the assembly drawing successfully. All right, so we are going to be creating the drawings depending on the member, so that we just want to avoid repetitions of members. Sometimes you can select all of these objects, all of this structure like this. If all is selected, you can just right click and then come over to create drawings, and then you can be able to create past drawings of this whole structure. You can be able to also create an assembly drawing of this whole structure. But meaning that most of the times, if I want to create my own drawings, I wouldn't do it like that. I created a drawing based on the members. Okay, I can just pick these members now and create an assembly drawing for this member, and I know that this type of member, I have it 1, 2, 3, 4. So any drawing result I have, I multiply by 4 to get the drawings for this particular member that is at the external, okay, edge of this structure. So I can pick this one for the internal. So this one now can serve for this and this. Okay, so we have 3 this side and 3 the other side. Altogether is 6. So if I get the drawings of this now, I can multiply it by 6 to get actual number and the detailed drawings of the intermediate stanchion successfully. And also, using that method will help you to be able to label all of your drawings successfully. But if it will actually take some time to be able to create drawings using that pattern. Okay, but I believe I've explained it. For the trusses, you just have to create drawing for one of the trusses, just one of these trusses, and then use it for the rest of the trusses successfully. So the pattern we're going to be considering now, we are going to be creating the whole drawing at once, so it will not take us much time. Okay, but if you check in my previous video on how to create drawing in Protek, still you will actually notice that it was that method I used successfully. So I'll be highlighting all of these members in this structure just like this, and I right click, and then I'll go straight away to create drawings. So I'll be creating assembly drawings right there. So if I click on create assembly drawing, it is going to create altogether 69 drawings. All right, so altogether 69 drawings. Okay, so let's wait for the drawings to be created successfully. Alright, so all the drawings is being created successfully. So what you just have to do, you just have to navigate to the drawing manager. Here is the drawing module. Alright, so you just double click on the drawing manager right there. So these are all the drawings that has been created successfully. So now if you select any of the drawing right like this, you can't just be able to double click on it. Once you double click on that, it's going to take us to the environment where we can actually see and edit these drawings successfully. So this particular one is still creating. Okay, altogether we have about 80 items inside of this particular drawings module right there. Okay, 80 items. So it's been generated. I'll close this now. So here are the items we are having. Okay, so now we have this, and as you can see, okay, this is a hollow square sections. Okay, 30 by 30. All right, so this could be the this could be one of the braces that we are having right there. Okay, so that is the issue we normally encounter creating drawings looking at the whole structure. Okay, but if you create it one by one, you can be able to easily identify the drawings that this one belongs to this place or the other one belongs to this other place. Okay, but once you create all the drawings at once, you find it difficult to actually identify where these drawings and which of the members are for this drawings successfully, because you may not necessarily see the name, but you may see the pack mark successfully. All right, so as you can see over here, we have a table here. So this table actually shows us the packed name, okay, the pack number, the pack name, and as well as the weight, okay, and the number required and the rest of that. Okay, so this is the drawing. So this drawing now can be exported to AutoCAD successfully. So if I should close this now, click on yes options, it will take me back to the environment. If I want to get back to the drawing modules, I just double click on these drawings and it take me to the drawing modules. I go to the drawings manager, and then I'll see all of the drawings successfully, just like this. Okay, so if I should select this now, and then I double click on that, it's going to also create a 12 numbers of items in this particular drawings right there. So you can now see we have these items, and here are the boats. Okay, we have 10 pieces of that. Okay, so here is the sections. Okay, the longitudinal sections AA. So you can see sections is being cut here. Okay, section AA of the boat. Okay, so now I want to be showing us something here before we actually transfer those drawings to AutoCAD. I'll show you something. Now if you want to see the scale of this, you can double click on this boundary, and then you have a viewport property editor. This one, this editor can come over to detailing, come to labeling right there. So you can drop this label outside. So say locate outside, click right there. So you can also change the font if the font is too big, and then activate the scale. It says text scale text settings. So you just click on this to check that, to have it activated. Once you click on apply, you have the the scale right there, which is 1:10. Okay, just like that. Okay, so the same thing is applicable to all of this. All right, so if you see some repeatable dimensions here, you can also dimension using these dimensions tools right there. Okay, so this is how we edit drawings in the Protek data. So this is actually the both drawings. Okay, so if you come over here, you can see the material list of the both drawings successfully, just like this. So you take your time to go through it and be able to study it for your understanding. If there is any question, you can actually drop it in the comment sections, which I'll answer you successfully. Okay, so without wasting much time, we will be exporting those drawings to AutoCAD. So what we need to do now is we have to close the drawing modules. So you click these permissions, yes options, to come there. At this point now, we double click on the 3D right there. Okay, we need to get out of this module, this drawings module. So you click in this close options right there. Okay, so we are here now. All right, so what we need to do, we need to export those drawings we created. Double click here to AutoCAD. So what you have to do at first, before we actually export those drawings, well, we need to get to the floor plan of this particular structure. So double click here. So close this. Here is the the foundations, the kind of foundations level. Okay, so in this foundations level, what we need to do, we need to be creating the sections that we created, those sections using the section box. Okay, so before you can be able to do that, you have to activate the 3D here. So right click and then create 3D view here. So this is the 3D view of the drawing here. Okay, so this is the same thing you are seeing in that template. Okay, this is how we create the same thing you are seeing in that template that I've shown to us. All right, just like this. So having created these 3D views, now we want to create the those sections that we actually formed. So we will come over to this 3D, select this 3D, click on this now. So once you click on this, it's going to create the sections automatically. It will automatically create the sections and it's actually loading. Okay, it is actually loading. All right, so you can see all of the sections has been created. So you can see what I was telling you. Okay, so this is the truss connections to the stanchion successfully. You can see how neat and good it is, and the leveling. All of this can be edited successfully. Okay, so this is the brace connections. Okay, so you can now see the way it's being arranged successfully. All right, so all of these are what you will actually use to arrange and put your drawing in order before you actually print it out successfully. Okay, so if you come over here, you can see how this place is connected on the polines and as well as the truss braces. Okay, in 3D view. Okay, so if you also come to where we have some of these brace connections, it also shows us everything in 3D successfully. As you can see, so there are some connections here. This is the plate connection, the goose plate. The base plate connections. All right, so you can see the 3D base plate connections. Okay, so if you come over to the main structure, you can see how busy this is. So what you just have to do, delete this. You have to delete this up because it's too busy and it's not presentable at all. So get it selected just like that. Right click and then you find a delete options. If you wouldn't see a delete options, you use the delete options on your keyboard to delete it. But make sure you get it selected first, just like this, and then you can actually use the delete options right there. Then click on yes options to get that deleted. So you can still bring it out if you wish. So you select the right click on create again. So you see this one is less busy now. Okay, so having created this now, we are good to go, and this is being created under story foundations. All right, under story foundations. So you have to take note of that. So this has been saved. Click on the close options and then click on the save. But before you should save that, just cancel it first. Come to this provision, these elevations. You have to also create them up there. So you can see our elevations right there. This one, I click and create it up there. So that is it. Okay, so we wouldn't have any need for all of this again. So let's check the roof. Create for the roof just like this. Okay, we have the roof here. Okay, so for these elevations, if for instance you want to do dimensioning, you can actually dimension this successfully. It's very easy. You can use the vertical dimension for the upward distance dimensions. Okay, so you can pick that point and all the way to this other point of green lines, and then be able to right click to place your dimension. This is 4,500, which is the height of the stanchions. Okay, so from the foundations right there, you can also be able to do your dimensioning successfully. Interrupt that and then pick the vertical dimension again, just like this. Pick this point, and then it actually dimensioned from green line point to green line point successfully. So you can actually place it here, right click to place it. That is 1002, the total depth of the foundations. Okay, so whichever dimension you want to do from this point. Okay, this is horizontal, so you interrupt, you have to pick the horizontal dimension 2. Okay, pick that point, come all the way to this point, pick that. Okay, so you right click right there to have 10 meters right there spans in that directions. So also you pick the if you want to make an angular dimensioning, this one you can use this for angular dimensioning successfully. So this is how all of this is being used. Okay, so where we are creating this is a story foundation, which is story F. Okay, so click on the close options and yes options to close this. Okay, so having closed this, get back to the drawing manager right here. So we need story F, we need this one. Okay, all of this you have to check them because we're exporting all of this now to AutoCAD. So we just have to check all of this that you created successfully. After having checked all of that, come to export over here, click on this export, and then you locate where you want to save this. Okay, so let's say for instance we are saving it inside there. Let's check videos, the videos. Okay, videos, and then we have a capture area. So I'm saving it inside video and captures. Okay, so click on the OK options, and then this altogether 14 items. So it's going to create all of the 14 items in that folders. Okay, so let's wait for it to get done. So you can see 14 of 14 items we created, exported successfully. So we click on done options. So after which you have just to close this, and then you can also close this. So we navigate to that folder right there. Okay, so we click right there, come over to this place. So these are all the drawings. Okay, that is being exported from Protek still to AutoCAD. So if you don't click on this now, it's going to open it in AutoCAD. So once it is open in AutoCAD, just like this, just have to zoom it. So these are your drawings. Okay, still drawings in AutoCAD, just like this. So having opened it here, what you just have to do, select all of these drawings right away. Once it's been selected, right click, and then go to clipboard, select copy right there. So having copied it now, you go to the still we have design template right here, this one, and then you have to just paste it here. So having pasted it, so you can see how tiny this drawing is. Okay, so if you compare it to this one, you see how bigger this is, and you can see how tiny this one is. Okay, so it will be somehow difficult for you to do your normal editing. So what you need to do is to increase the scale by 100. Okay, so what you just have to do, get this drawing selected. Okay, after having it selected just like this, just type XC on the keyboard, enter. Alright, so having enter, pick any point right there, move your hand this way and key in 100 and then enter. So once you enter, if you scale these drawings so that it can be more visible to this, so you can now see now. So having scaled it to these drawings now, you can now start to carry out your editing. You can first of all copy from this point, copy this out just like this. After you copied it out, you can see all of the connections right there. Everything is actually showing in the 3D format. So this one now is your 3D, which is the same thing as this 3D you are seeing here. Alright, so you now start to carry out your foundation layout, which is the same thing you have here. So you just have to reference this to edit all of these you are drawing successfully. So if you get back to the folder where we have these two drawings right there, the second one we are having here is this one. Double click right there, and you also have all of these drawings as well as sections just like this. The same method you have to use. Okay, So you just have to select all of this, just like this, right click, copy it to clipboard, and then you navigate to the steel wheelhouse template right there, and then you have to paste it here. So pasting it, you can see how small it is, just as I've told you earlier. I like this scale XC on the keyboard, enter, and then pick on these drawings, move your hand this way and key it 100 so that you can meet up with the existing scale of this drawing environment. Okay, click on the enter options there, so to have it. Okay, so this is now on the same scale with these other ones, so you can easily arrange and edit all of this successfully. Maybe if you wouldn't have a good understanding of this, I want to invite you to join our ongoing masterclass training program. Okay, so you can inbox us through the link in the description of this video if you really want to learn and understand very much. But if you can't, I believe with this help of this template now, you can be able to arrange your drawing successfully. But if you want to learn more and understand the nitty-gritty of the Protek steel and software like Tekla, SAP 2000 ETAPs, okay, you can inbox us and then enroll in our training program, as we will train you to a professional and master levels of using of this program to produce a detailed drawing just the way you are seeing right here. Okay, so this is how you actually produce your drawing. So if you navigate to the Protek structural complete template for the past footage, you still have your drawing. So you have to edit your foundations using this particular template. Okay, and then your spark structure, you now edit it using this template successfully. Okay, so I believe this has actually explained deeply on how you can successfully organize your presentation drawings Protek steel successfully. So at this point, we will say that if there's any question, drop it in the comment section. Don't forget to like. Do not also forget to subscribe to the channel. So stay tuned for more advanced lesson. Bye for now.